Hello, I'm JW. Now, several people have actually asked how the tests are done outside, like that last video with that melting cable, and the obviously setup with the controlling the current through the device. So I'll show you how this has been done. It's actually fairly straightforward, but do bear in mind that the whole point of this setup is to essentially cause things to destroy themselves, melt, overheat, and possibly set on fire. So obviously there are certain risks involved in doing that. And bear in mind that it's mains voltage electricity as well, so certainly not something you want to be poking your fingers inside, and obviously proper safety precautions have to be taken. But anyway, it is quite a straightforward setup. Basically involves the variac and a transformer, and obviously various bits of wire and connections. Now we're outside here, and the first item is this variac, which is essentially a variable transformer. And you see the two blue leads there, one of which just goes to a normal 13 amp plug, so that's where the mains comes in, and then the other one just comes out of there. And the lead coming out has a variable voltage on it, and that can be varied between 0 and the full mains voltage of 240, and that's done by using that metal silver knob on the top there. And we've also got that black switch, which is an isolating switch, and that can also be locked in the off position as well. And this particular variac is fairly old, although it has been completely refurbished and repainted. And I've actually done a whole video series on that particular thing, and links to that are in the usual place. Now this variac is only rated to around 8 amps maximum, which of course is not a great deal when you're wanting to test things in a sort of 15 to 30 amps range. So in order to avoid overloading this device, we've got another transformer connected to the output of this variac. And so you've got that black mains lead just plugged in there. And that goes straight into this yellow transformer here. And this is one of these building site type of transformers, which normally accepts 240 volts on the input via that black lead, and then gives 110 volts on the output via those yellow sockets. Now these are actually wired up in such a way that instead of it just being 110, it's actually two lots of 55. And this particular plug with the orange lead in is wired up in such a way that it only uses half of the transformer. So essentially if we put 240 volts in, we're only going to get 55 volts out. Now that's roughly a 4:1 ratio, not quite, but the point of this means that we can actually get out of this about 4 times the current that we would get if we just use the variac on its own. Basically it's stepping down the voltage considerably, so even if we put say 8 amps in, we can in theory get in the region of sort of 30 odd amps out of it. So the orange lead from there is just a 2-core flex, actually 1 square millimetre in size, and that simply just comes out of there, and then at the end of it just got those 2 connectors which we can attach to whatever the thing is that we're actually testing. That remains that black and charred lead in this particular case. So that's the entire setup. So basically just the mains into the variac, so we can adjust the voltage, and from there into that transformer, so essentially we can get more current from it. Basically it's cutting down the voltage to 1/4, and hence we can have about 4 times the current out than we would have normally. So with an 8 amp input we can get in the region of sort of 32 amps out without actually overloading the variac. Now in terms of controlling the current, it's purely down to the input voltage, so by increasing the voltage on the variac there, then of course we'll increase the current coming out at the other end. Now that has one disadvantage in that if the resistance of the item under test changes, then it will be necessary to adjust the voltage to compensate, and you've probably seen this in some of the other videos, where if you're heating up a piece of wire, for example, the resistance will increase, and therefore the current will actually drop off slightly, but that can be compensated for by just slightly increasing the voltage there. So a quick look there at the arrangement for testing. And I say that thing can do up to 30 amps. Now for currents above that there is another device which is used, and that's the one that goes up to 140. I'll show that in a separate video, as that piece of equipment is currently stashed away inside, so we'll have to drag that out. And videos like that generally only get done in the summer or better weather, because unfortunately in the winter the rain or whatever tends to put a stop to that kind of thing. So there should be more of those coming up in the fairly near future. But until then, thanks for watching.